For number 2, initially there's 0.6 molar A. Once I see initially, I'm doing a nice chart. 2A is in equilibrium with B plus C. My initial value of A is 0.6. If I'm not given a starting value for anything, I assume it's 0. Since the right side of the reaction starts at 0, I know this side has to increase and the opposite side is decreasing. I fill in number of x's based on the coefficient. So since it's 2a, it's going to be 2x, a single b, and a single c. I'm going to write my equilibrium expression, b times c over a squared. For this problem, I don't know any of my final concentrations, but I know every one of them in terms of x. And I know my k value. So I can plug all of this into the equilibrium expression and solve. My k value is 9. 9 equals x times x over 0.6 minus 2x quantity squared. This is the same thing as 9 equals x squared over 0.6 minus 2x quantity squared. Since both the numerator and the denominator here are perfect squares, I can square root both sides of this equation to solve. I don't need the 9 to be a perfect square for this to happen, because if it was an 8, I can square root that in my calculator. So I'm going to square root both of them. Square root of 9 is 3. The square root of x squared is x. And the square root of the denominator just takes away the squaring term. Now I'm going to cross multiply. I'm going to distribute 3 times 0.6 is 1.8 minus 6x equals x. 1.8 equals 7x. X equals 1.8 divided by 7, 0.257. Now that I have that, I can plug it back in to get all my final concentrations. For A, 0.6 minus 2 times 0.257 equals 0.086. My equilibrium concentration of B is x, and C is x. So for at equilibrium, B is 0.257. And then the other part of the question, the percent A turn to product. For percent turn to product, it is always going to be done as the change over the initial times 100. This is my change, which is 2x. This is my initial, which was 0.6. I'm going to ignore the negative sign because it's always going to be a change of disappearing reactant to turn into product if I'm asking you this type of question. So 2 times 0.257, or 2x, is my change. The initial is 0.6 times 100 gives me 85.7%.